All right, so good morning, everyone. Today we're going to talk about cladograms. And so today is going to be a bit of an overview, so let's go ahead and get started with that. So just sort of the quick schedule for the day, I'm going to briefly go over the asynchronous assignment instructions for whatever day that you are learning asynchronously. And then we'll have a quick Bellwork and review. We'll kind of go over what a cladogram is, and then we'll work on practicing with the worksheet. Okay? Pretty simple. So, if you are asynchronous and you're watching this video at home, you have two things that you should be doing, and there will be a link to the PowerPoint in the description as usual. You're going to do a very cool overview of the sort of evolutionary tree of bears, and then you're going to practice kind of try to work on building cladograms with some pre-selected species in a interactive online version of what we're going to do in class. Okay. So in class, we are going to work on a worksheet called Using Cladograms. You can make a copy of this either in Canvas, or you can click the link in the description to make a copy, or maybe you've already clicked this link in your own version of the PowerPoint. So it's going to look something like this. Make sure you put your name not only in the header, but also make sure and you go over here to the top and you put your name into the title so it's easy for you to find later. That's very important. Okay, I'm just going to put my name in here. I'm Miss Y. Y'all know that. Oops, there we go. So this is where I'm going to put the link to the video that I'm currently recording in a moment. But before we sort of get started, I want you to think back to Tuesday and Wednesday. What did we learn on Tuesday and Wednesday? What were we addressing or trying to find out? And the question that I want you to take about 2 minutes to answer is, before we talk about cladograms, what do we already know can tell us that a species is more related to another? All right, so pause the video, give yourself about 2 to 3 minutes to write down, try and get at least 2, but go for 3 if you can, ways that we can tell species are related. So pause the video and work on the Bellwork question on the worksheet. All right, so hopefully you recalled our 3-letter acronym that we learned on Tuesday and Wednesday, FAM, FAM, fossil evidence, comparative anatomy, and molecular biology are the 3 main ways that we focus on proving evolution, and thus the idea that most things are related to some degree. All right, it's just a matter of, all living things are related, but we're just trying to figure out how much they are related. So the idea with cladograms is kind of giving that relative relatedness. But remember, fossils, comparative anatomy, and molecular biology. This is a diagram of what the cytochrome C protein actually looks like. So pretty cool looking. All right, so what is a cladogram? What the heck is that? Sounds like some sort of weird jam or something, right? So a cladogram is a diagram that shows relationships between species. This is an example of one. This is a primate cladogram. So we have humans at the very end here with chimpanzees and the gorillas real close. The gibbons, siamangs, the lesser apes. So we got apes, great apes. We got the monkeys, old world, new world, all sorts of things that a primatologist would be a lot more interested in. But we're talking about how they're related to each other. And so we can see this visual representation of relatedness. It's kind of like a family tree, okay? Or a pedigree, what we were working on earlier in the semester using the pedigree with the different traits that we were tracking through a certain family. This is species-wide, okay? So it can also include traits, but it doesn't always include traits. But there are other names that are usually interchangeable or used in addition, such as gene tree, evolutionary tree, cladogram, phylogenetic tree. Just all a little bit different, but you'll likely hear a lot of those as we continue to learn about this, or if you look more into it. So if you want to learn more about cladograms, how to read them, how to draw them, we're going to go just a little bit into this, not as much as we would in a normal school year, but I did want to give you some resources that you can look into if you're still confused by the end of this video, or if you just like, ooh, that's kind of cool, I want to learn more. So there's 5 different videos there. 2 are in Spanish, yellow and green here, and then the rest are in English. So on your worksheet, the official definition of the cladogram, okay, is a diagram that shows the evolutionary lineage from a common ancestor, as well as traits that evolved along the way. So I want you to take about a minute, pause the video, because you can see this on me. Pause the video, go back to your worksheet. You should see the orange blanks. Make sure you fill in that definition for what is a cladogram. All right, so now that you've got that definition down, fantastic. Just a quick little fun fact. So we talk about the idea of a common ancestor. Now, all mammals, all right, that means me as a human, that means cats, dogs, mice, rats, bears, llamas, camels, whales, dolphins. I keep going down the list. Bats. All of the placental mammals, so mammals that carry their babies in their womb, have a common ancestor in this teeny little shrew. So shrews about this big. Okay, I don't have a good. Where's the pencil case? Probably not. This is the pencil case. So it's got pencils in it. Sorry, didn't mean to drop them. But it's probably about this big. Not including the tail. You might add the tail. The tail might be longer. But that's our sort of our idea of what is the common ancestor for all placental mammals. So over time, through natural selection, through environmental pressures, we see that this is the sort of great times a million grandmother of all of the mammals that are currently existing here on Earth, placental mammals. So it's kind of cute. I mean, it's got like a possum kind of face going on there. I mean, it's a little cute. All right, so let's take a look at some textbook cladograms, right? So we have some common types of cladograms. Sorry, I grabbed something. So we got some common types of cladograms here. I'm just grabbing my tablet so I can draw on these. So sometimes they will be sort of the slants, all right? Kind of reminds me of a triangle. And sometimes they'll be more of the kind of rectangular type. So there's 2 main types, but these are both considered cladograms. So you might see different versions of them. Here's an example of sort of the triangular version. All right. And then here's an example of kind of a hybrid. It kind of went from this way to kind of like that way. So it's a little more of the triangle. But we are also seeing that they are not only showing the species like this one was, but they are also showing the traits. So this one here shows how these traits diverge. And we'll talk about how to identify who has what traits based on the cladogram. Okay. So on your worksheet, you have this particular cladogram. So we're going to take a closer look at this cladogram. I'm going to have the pictures on the screen so you don't have to keep looking back and forth. All right. So taking a closer look here. In order to read a cladogram, we must be able to recognize that there is, first of all, a timeline. And second of all, there is a greatest common ancestor. When I say greatest common ancestor, might kind of sound like math, greatest common denominator, right? That means that's the ancestor that all of the animals or species, organisms on the cladogram, they all share. So kind of like what I was talking about, that cute little weird looking animal that is the common ancestor of all mammals, that's the greatest common ancestor of all mammals. And so that is going to be the oldest part of the cladogram. So you can see here at the top, I should put my laser pointer on. You can see here at the top, oldest is on the left here. And as it goes to the right, we get to more recent creatures. So all of the animals that are here are recent. These are actually currently existing. And then all the way back here is things that are long extinct, way, way, way have been dead for such a long time. And so as we move through here, we start to see over time, we have traits that evolved. We have divergence where they split up. All right. And we eventually go closer and closer to current modern times. So remember, greatest common ancestor is the oldest part of the cladogram, and all the species are the youngest or the most recent part of the cladogram. Okay. So when we talk about determining relatedness, and I'm going to do a couple of examples of this in a little bit, so like don't you worry. We want to look at how quickly do we find their common ancestor. Okay, and so there's the greatest common ancestor. However, each species do have their own common ancestors. So for example, we have the common ancestor between the turtle and the leopard. And so as we trace their lines, we want to find the quickest junction, kind of like a streets crossing, right? So, okay, we're like, oh, look, they meet here at that line. So that is their closest ancestor right here in this blue circle. And so the longer ago two species shared an ancestor, the less they are related. So these two have a very recent ancestor. That was like quote unquote yesterday for them. However, if we want to compare the leopard to a different animal, such as the bass, which is this fish here, we have to take the leopard. We're going to trace, I'm going to show this on my tablet as well, so you'll see a little bit better. But we're going to trace this all the way back to these hinged jaws here, and that's where the bass meets up. That's the first time that they come back together and they meet up. And so that was a long time ago compared to this ancestor here. And so we know that the leopard and the turtle are a lot more related because they have a more recent common ancestor versus the bass and the leopard, which have a older common ancestor. Okay. Yeah. All right. So we also can use these cladograms to determine what traits an animal has. So this is when you're just taking one species and you're going to trace from that species all the way back to the greatest common ancestor. And so there's a lot of tracing involved. I know when I do cladograms, I usually have my fingers on the screen or on my fingers on the paper, and I'm just tracing, or I'm using colored pencils. And I'm going to show you how I do that with my drawing program in just a moment. But I did want to highlight this so you could see it in the PowerPoint in case you didn't feel like watching the video again. So we can see that the bass, if we trace back, has two traits: hinged jaws and a vertebral column. Those are the only traits it has. We see the turtle. We trace back to the greatest common ancestor. We have an amnion, 4 walking legs, hinged jaws, vertebral column. So 4 full traits on the way back to the common ancestor. So they're kind of like tracing their roots. Okay, and you see what they basically picked up, what traits they picked up along the way. Okay. You'll also see that there's a outgroup. All right, this lancelet, it's like a very angry looking piece of toilet paper fish. All right, it is called the outgroup. It actually, as you trace it back, you'll see it doesn't have any of those traits. It's kind of like the outsider. So that's why it's called the outgroup. It's just like it doesn't have any of the traits. It has very little in common with the rest of these species here. All right, so on your worksheet, there is a section below the cladogram, which is already completed, and it asks you to use that cladogram in the method that we just did with the tracing to actually fill in this chart. Okay, so I just did this first row for you so you can actually see how that's represented. So an X means it does not have the trait. A O means it does have the trait. Obviously, a check mark would be better, but check marks are a little hard to do on the computer. So we're just kind of using O as like a placeholder and an X as a nope. So take about 2 minutes. No, let's take 3 minutes, because if you're going to do all the tracing, make sure you're doing the tracing. You're looking at each animal, what traits it has. All right. So pause that. And I'm also going to show this on my computer. So if you want to keep watching rather than pausing, then just keep going. All right. So let me just take a try to give you all a, let me make this opacity lower, and I'm going to use red to start with. So, nope, a little too opaque and a little too small. All right, so let's take a look at the lancelet, right? We're going to see what traits the lancelet has. So we're going to trace this back to the greatest common ancestor, which is here. I'm going to a little too big. I'm just going to abbreviate greatest common. Gotta move over. Greatest common ancestor. Okay. So, lancelet doesn't have any traits. Let's go to an orange. I'm going to change the opacity just a little bit. Okay, we're going to look on the lamprey, another weird looking fish. So we're going to trace from the lamprey back to the greatest common ancestor, and oh, vertebral column. So the lamprey does have a vertebral column. It doesn't have anything else. All right, hit the yellow. Let's look at the bass. So we already looked at the bass, but we're going to look at it again. So from the bass, we're going to go to hinged jaws and vertebral column. All right, so that has 2 of the traits. Cool, very cool. Looking at the green for the frog. How fitting. Frog goes down. Oh, we got the 4 walking legs. Very cool. Also has the hinged jaws, vertebral column, all the way back to the greatest common ancestor. So has those 3 traits, but not these 2. All right, hit that light blue for the turtle. We're going to go, we did the turtle already, but again, amnion, 4 walking legs, hinged jaws, vertebral column, greatest common ancestor. You should start to see a trend here, right? And then last but not least, the very cool leopard has hair, very special. The only one on there has hair. And then it has, of course, the amnion, the 4 walking legs, the hinged jaws, the vertebral column, all the way back to the greatest common ancestor. So we see how that works. And so you see how you can actually trace them and actually look at how what traits they have. We'll do relatedness in a second. But take a moment to make sure you've got your chart filled out on your worksheet. I like to use all caps just to make it very big. So the lancelet has none of these. The lamprey has only the vertebral column. The bass has the hinged jaw and the vertebral column, but nothing else. The frog has the hinged jaws, the vertebral column, the 4 walking legs, but not the amnion, not the hair. The turtle does not have the hair, but it has everything else. And the leopard has everything available. So you can actually see how this kind of shows a pattern. Lancelet has absolutely nothing. We start with that and go all the way up to the leopard that has absolutely everything. Pretty cool. So your next course of action is to work on page 2. You can pause the video here, stop the video here, or work with your teacher, or work on it independently, or you can keep watching, and I'm going to keep explaining page 2. Hopefully I haven't taken too much time to do the first part. Let's get started on page 2 if you want to keep going with me. Otherwise, work on it yourself or work on it with your teacher. But make sure you get it done. So we're going to do 2 things here. We're going to complete this chart. All right, I'm just gonna screenshot this and take it over to my drawing program because I like my drawing program. And create from clipboard. Boom. So first thing is we're going to fill in this chart. Okay, based on things that we already know. All right, this is nothing special. We're talking humans, we're talking snakes, monkeys, and lizards. We got hair, legs, opposable thumbs, so that means thumbs like these, because opposable means it can do this, right? And then we got eyes. Pretty cool. So let's take a look, and it might not be as pretty, but we're going to use the same thing. So if it is, let me make sure I got the right outline. All right, I'm gonna make another layer here. There we go. So if it has it, it's going to be an O. If it does not have it, it'll be an X. So think along with me. Humans, we got hair. All right, we're going to put an O. We got legs. Oh my gosh. We got legs. All right, I'm going to put an O. We got opposable thumbs. Yep. And we have eyes. So we have all of those things. Sweet. Now, what about a snake? We all know what a snake looks like. Does a snake have hair? Nope, it's got scales. Legs? No legs. Opposable thumbs? Nope, no opposable thumbs. Eyes? They sure do. So they do have eyes. Cool. Right, what about a monkey? Okay, a monkey's got, yeah, monkey's got hair. Monkey's got legs. Yes, monkeys do have opposable thumbs. They got the good for climbing. And yes, they do have eyes. What about a lizard? Okay, lizard looks like they have, nope, don't have hair. Do have legs. Do not have opposable thumbs. But they do have eyes. So there's our chart. So you're just kind of asking yourself, does this species have this trait? That's all you're asking. All right, so now we got that chart filled out. What we got to do is fill out the cladogram. Okay, and I think I'm just going to do this on this just for the sake of time. So, as it says, you're going to click on this picture, and below it, it gives you the option to edit. You're going to click edit, and it's going to allow you to actually edit it. Try not to move it. This took a while to put together. So, you can save and close as much as you need in order to go look at your notes, perhaps. Or if you're really, really cool, you could take a picture with your phone of your finished chart and then use it to work on this. But you didn't need me to tell you that because y'all are smart. You would have done that. So click this, edit, and let's put in the labels. So let's actually read the instructions first. So it says, label the chart with the following: evolve first, least recent, and evolved last, most recent. So I'm going to click this. We're going to edit. All right, so we know that this is time. This is an arrow going this way. So this is got to be least recent, which means that it evolved first. So it was the first thing. Ooh. Looks like that's a little too big there. Let me make that a little bit smaller. So least recent evolved first, which means that this label must be most recent evolved last. Okay, because the most whoops. Sorry. The most recent species are the ones that most recently came about. Okay. So, okay, cool. We did that. So we're going to save and close. It's going to update this. We're going to read the instructions again. Okay. It says put the animal with the least traits closest to the common ancestor. Okay, we see where the common ancestor is. We want the animal with the least traits. Let's go look at our chart. The least traits. Otherwise, who has the most X's or who has the least amount of zeros? So let's just do a tally up right quick. Let's see. Humans have 1, 2, 3, 4 traits. Snakes only have, one trait. Okay. We have monkeys with 4 traits. And we have lizards with 2 traits. So the least amount of traits is the snake. So we're going to go here. We're going to go to this animal here. We're going to write in snake. You can make it pretty. I'm not going to spend too much time. All right. So we're going to put the animal with the next least traits to the right of that animal. Okay. Next least traits, as we did see, was the lizard. And then human and monkey are tied. We're going to go back to that in a second. So got too many windows open. So we said lizard. All right. And then human and monkey are tied. But we know, just based on what we've learned so far, that humans are the most recent evolution. So we're going to put monkeys here because they're before the evolution of humans. Okay, and that's just something that we kind of know already as scientists and as biology students. We kind of know that. So snake, lizard, monkey, humans. All right, we still have the traits though. So now we're going to go back, look at the instructions. We're going to save and close. All right, and then put the trait that the first animal has before the first animal's line branches off from the main line. Okay, so that one trait that the snake had, what was that trait? Let's take a look. Snakes have eyes. So that means that the trait of having eyes evolved before snakes branched off. So we're going to put eyes here. Because remember, when you are drawing back to the common ancestor, it has to cross over any trait that it has. So we need to make sure that the snake, when you're drawing back, crosses past the trait of eyes back to the common ancestor. So we're good there. All right. That means that whatever is here in this second trait, the lizard has to have. So what's that next trait? So lizard has 2, has eyes, which we already have, and legs. Okay, cool. So go here. Got legs. So we know the lizard has 1, 2 traits on the way back to the common ancestor. Boom, makes sense. Now, we've got monkeys and we've got humans. We know they both, that's Spotify, there we go. They both have legs. No, sorry, they both have hair and opposable thumbs. Those are the 2 new ones. So we need to make sure that wherever we put those traits, both humans and monkeys trace over those 2 traits on the way back to the common ancestor. So we have 2 traits. I'm going to put hair and opposable thumbs. Oh, that's a big box. We need some smaller font there. Opposable thumbs. There's an extra number in there. All right, opposable thumbs. So now we have 2 traits. Let's double check. We go from monkey all the way back to the common ancestor. We trace over 1, 2, 3, 4 traits. Good. Humans tracing over 1, 2, 3, 4 traits. Excellent. So we know we're good to go. So you have completed your cladogram using just that chart. All right. So it is up to you to work on questions 1 and 2, which give you a chance to sort of analyze. Quick. Give you a chance to analyze those cladograms. I'm gonna make a separate video just because I feel like this one's really long already. To talk about determining relatedness. But otherwise, you're done with this worksheet and keep up the good work.